Hi everyone, welcome to ACER Explained. This is a series where I'm going to go through section 3 of the ACER Practice Question booklet. So please have that booklet open in front of you because for copyright reasons, I won't be able to have any of the questions on the screen. So having that booklet will help you follow along. Let's jump into it. So we're starting off with Unit 1, so that's questions 1 to 5. What I'm going to be doing throughout is identifying the prerequisite knowledge that you might need to answer these questions. I'm going to be identifying reasoning skills that you can use to answer these questions as well as outlining some of the bootcamp resources that could be helpful to develop these as well. So let's start off with Unit 1. In Unit 1, we're given the pulmonary circulation of a fetus in a diagram format or sort of a flowchart format as well. And we're given some information in paragraphs and we're being asked the following 5 questions. So starting off with question 1, this question is asking us at which one of the following points M, N, L, M, N, or L is the blood that's passing through. At which point will it be more oxygenated after birth compared to before birth? Okay, so first of all, we need to scan the important information and pick out the important information, which I've put here. So the important information we're looking for is at birth, right? So the ductus arteriosus and the foramen ovale close at birth. So outlining where this is the ductus arteriosus, this like little duct here, and then this is the foramen ovale, okay? At birth, these close. Then we're looking at these points, M, N, and L, okay? So looking at, let's start off with point M, okay? Now, it's quite downstream from the ductus arteriosus and foramen ovale. It's quite downstream, right? So out of these options, this doesn't seem like the one that's going to be impacted. Further, it's actually after the systemic circulation of the fetus. So if you know what the systemic circulation is, that's kind of when the blood goes through the rest of the body. The pulmonary circulation is when the blood goes through the lungs. And so after it goes through the rest of the body, it's going to become deoxygenated and reach M. So that's going to happen regardless of whether ductus arteriosus and foramen ovale are closed or open. So we're kind of tentative about M here. Then we're looking at point N. Okay, so point N is right here. Point N is getting blood from the pulmonary circulation and it's getting blood from this side of the heart here. Okay, and that's through the foramen ovale. So we already know that the foramen ovale is relevant here. Now, this point, this chamber here is receiving deoxygenated blood from systemic circulation, as well as from the maternal circulation. It's getting deoxygenated blood. We know this because systemic circulation uses oxygen, and from here, it's getting pulmonary blood, so that's going to be oxygenated. Okay, so before birth, it's getting a mix of O2 rich and O2 poor blood. Now, when this closes off, so let me use a different color here. So when this closes off, it's only going to get blood from the pulmonary circulation. So it's only going to get O2 rich blood. Okay, so that means that after birth, once this foramen closes, the blood there is going to be more oxygenated than compared to when the foramen ovale was open before birth. So we can already kind of see that N is the correct answer, but let's move on to the next option just in case. So again, L comes after the systemic circulation. So with the same reasoning that we eliminated M, we can also eliminate L. And we know that because B is the right answer, it's not going to be D either. So we can circle B and move on. So for this question, the previous knowledge that you did need was that blood gets oxygenated in the pulmonary circuit and deoxygenated in systemic circulation. And you also did need to use the reasoning skills of extracting important information, as well as deciphering flowcharts. So you should have been able to tell kind of like what's more downstream in this flowchart versus what's upstream. And you also need to use the process of elimination as well. The bootcamp resources that can help with this are the acceleration class on diagrams and introduction to visual stimuli, as well as our introduction to reasoning acceleration class. And there's also the content in action on cardiovascular and respiratory systems so that you're more comfortable with working with these kind of biology concepts. Question 2 is asking something similar to question 1, except this time it's asking which of the following points is going to have blood passing through that is significantly less oxygenated after birth compared to before birth. And so similarly, we have this important information. At birth, the ductus arteriosus and foramen ovale close. So just highlighting those once again. And then we're looking at K, L, and P. So I'm going to start off with P this time. P is right after the pulmonary circulation, and so it's not going to really change much. You're still going to have the same amount of oxygenation before and after birth. Well, given this information at least. Oh, so we're going to eliminate P. Then we have K. So we have K that has blood coming in from this little area and this little area. And after birth, this is going to be closed, but this is still going to provide blood. Okay, so we're going to, after birth, get more blood from this chamber here. So I'm going to just call this, let's call this chamber 2 on this side and chamber 1 on this side, okay? So after birth, you're going to get more blood from chamber 2 and less blood from chamber 1 because the ductus arteriosus is going to close. And chamber 2, as we saw from the last question, and as we can see now, is receiving oxygenated blood here. So this one has greater amounts of oxygen, whereas chamber 2 is getting deoxygenated blood. So technically, point K is going to be more oxygenated after birth than before birth. And we're looking for something that is less. So we can eliminate option K. Finally, we're looking at option L. And similar to before, it's after the systemic circulation, so it's not going to really be impacted by something so upstream as the ductus arteriosus and foramen ovale. So we can eliminate that one too. So the correct answer in this case is actually D, neither A, B, or C. This question also required the prerequisite knowledge of some basic biology, which is that blood gets oxygenated in the pulmonary circuit and deoxygenated in systemic circulation. It's the same reasoning skills as before and the same bootcamp resources that I mentioned earlier as well. Question 3 is referring to the following additional information that I've drawn up onto the screen here. We're given an equation and we're given a bit of a diagram as well. And initially, this is quite intimidating, but the question itself is actually just asking what of the 4 options is the unit gram per liter equivalent to. So you might initially think, okay, well, I might need to put this into this equation, etc., etc. But you'll quickly realize that you don't actually need any of this information in order to answer this question. All you need to do is some dimensional analysis. So let's start off with option A. We have minutes per liter times minutes per gram. And we're just going to multiply these. So we have minutes squared and per liter gram. And so this does not equal grams per liter. Looking at option B, we're going to do the same exact thing. Liters per minute times grams per minute. And that's going to lead us to this. And this is also not equal to grams per liter. So let's move on to option C. So we have liters per minute divided by grams per minute. And this equals to liters per minute multiplied by minutes per gram. So the answer that we get here is liter minute and minute gram. We can cross these out. So we get liters per gram, but that doesn't equal grams per liter, which is what we're looking for. Then finally, we get to option D, and we do the same thing. Grams per minute divided by liters per minute, which equals to grams per minute multiplied by minute per liter, which equals to gram minute over liter minute. We can cancel these out and we're left with grams per liter. And so this equation here is equivalent to grams per liter. So yeah, we didn't actually need to use any other information for this question. So for this question, you actually don't need any previous knowledge like I mentioned. And the reasoning skills that I used are dimensional analysis. Dimensional analysis is super important in the GAMSAT because you can sometimes figure out answers to questions just by looking at the units and not even looking at or doing any of the other calculations, just by looking at the units of the answer and the units of the question. And so the Bootcamp resources that can help with this are our dimensional analysis video, as well as our reasoning skills course that can help you learn how to look at questions in this kind of a way. In this question, we're asked to use this additional information once again, and we're being told about the Fick method. And so we're given here a diagram of point X and point Y and an equation for flow rate. And then the Fick equation, or the Fick method, is referring to it's talking about how we can apply this in biology. And so it's saying that basically the stuff that's introduced here, instead of dye, it is a substance that already exists in the blood. So for example, oxygen. So we're given this example for chimpanzees that in an adult chimpanzee, the lungs will add 240 mils of oxygen per minute. Okay, so when I see per minute, I'm thinking, okay, well, over here, we've said over 1 minute. So this is probably something to do with this diagram. It's probably something to do with this equation. And so what we're being asked is that what does point X kind of correspond to in the situation that's depicted in figure 3, which is the one with the chimpanzee. So is it the lungs? Is it the pulmonary artery? Is it the right side of the heart? Or is it the vein entering the heart? So we know that at point X, we need to add a certain quantity of dye, which is, in our case, oxygen, over 1 minute. So if you look at this question and you're like, you kind of use your pattern recognition skills, you'd be able to recognize that, oh, I was actually told earlier on in the stimulus that the lungs add 240 mils of oxygen each minute. And so this kind of matches up to what X is showing us. And so we can figure out that X is the correct answer. So point X, the most important thing is that there's something being added. The oxygen is being added. And the pulmonary artery doesn't do that. Neither does the right side of the heart, and neither does the vein entering the heart. Although, veins entering the heart could potentially carry oxygenated blood. It's not adding the oxygen to the blood, right? So basically, if you were unsure, you'd be able to eliminate these 3 options. And you'd only be able to eliminate these 3 options if you had the prerequisite knowledge of what these structures do. But by just using pattern recognition, you'd be able to recognize that they literally say the lungs add 240 mils of oxygen over 1 minute. And so A is your correct answer. So again, no previous knowledge required here, but the reasoning skills that I used are being able to extract the relevant information, not being distracted by all of the additional information that's there, as well as pattern recognition, as I mentioned earlier. So some bootcamp resources for this are the Introduction to Reasoning Acceleration class. The Calculations and Formulae Acceleration class will help with some of the calculations as well that would come up later on. And the Diagrams and Introduction to Visual Stimuli Acceleration class. So with question 5, we finally have a calculations question, and we're being asked to calculate the cardiac output for the situation that was shown in figure 3, for which we're given information here. And the cardiac output, we're told, is essentially the flow rate. So we can use this formula or this formula to calculate that. I would prefer using this formula because given the information, we already have the quantity. So we have Q, and then we also have delta C, which is just going to be this minus this. okay, because it's the oxygen that's flowing into the atrium and leaving the ventricle. We don't necessarily have one at point Y specifically, which is why I'd be iffy with using this calculation, but we have the difference in the oxygen concentrations. So that's why I would use this formula. So just filling that in now, F is equal to Q, which is 240 milliliters per minute, over delta C, which is 180 minus 120, so that's 60 milliliters per liter. And what you're going to do is basically just divide, so you're left with 4 milliliters per minute over 1 milliliter per liter. Now we have to figure out what's happening with these signs. Okay, so milliliter and milliliter are both here, so I would cross them out like that. And then we have 4, 1 over minute over 1 over liter. And because these are both inverses, we can just swap them around. Or what you can do if that doesn't make sense to you is basically go 1 over minute divided by 1 over liter is equal to 1 over minute times liter over 1. And that is liters over minute. So you're left with liters per minute. So you're left with 4 on 1 liters per minute. So the answer is 4 liters per minute. And that's how you get to that answer. Again, this question required no previous knowledge. All you needed to know how to do were the calculations, just plugging things in, and being able to extract that information from the writing and being able to translate that into the formula is quite important. And that will come with practice as well as learning how to do reasoning, which you can learn through our reasoning skills course. And then also we have dimensional analysis that's being used here as well, because we had to remember the units that were being used, because as you saw in the answer options, there were some options that looked similar but had different units. And so being able to do that dimensional analysis is quite important too. So some of the bootcamp resources that you can use are the Introduction to Reasoning Acceleration class, the Reasoning Skills course, as well as the Calculations and Formulae Acceleration class. That brings us to the end of Unit 1. Thank you so much for watching, and like, share and subscribe for more GAMSAT help. We really value your feedback. And follow along with this series. We're going through the entire booklet, and our Instagram is at ThankFlipGamSat, as well as our podcast, ThankFlipGamSat, Nurses Doing GAMSAT, if you want to hear more from us. All right, I'll see you in the next one. So that brings us to the end of Unit 1. Thank you so much for watching. Please like, share and subscribe for some more GAMSAT help. We really appreciate the feedback. And we have our Instagram at ThankFlipGamSat, as well as our podcast, ThankFlipGamSat, Nurses Doing GAMSAT, if you want to hear more from us. But other than that, I'll see you in the next one.